Hey guys, welcome. My name's Erin. I am in and out of town a little bit. I am the environmental coordinator for the Native Village of Eyak. And this is part of a project that we've been working on together for about a year. It's called the Arctic T-Slip Project, or the Arctic Tsunamigenic Slope Instabilities Partnership, which is quite a mouthful. And we have online one of our colleagues, a geologist, Higman, who will be talking about landslides and landslide risk, especially because of permafrost thaw and glacial retreat around this area. You guys are welcome to grab some food. We've got some sandwiches over there. I'm a little bit out of breath because I just ran a bunch of drinks down the street. And we actually, if you're willing to hang around afterwards, we wanted to have a little bit of a workshop and talk a little bit about what we might be able to do in Cordova about some of these risks and think about some next steps. So I guess maybe let's take 5 minutes, and if you guys want to grab some food, please go ahead and we'll get started with the presentation in about 5 minutes. Whew. Excuse me for being out of breath. Yeah. Yeah, we got sandwiches. There's BLTs, meatball sandwiches, and veggie sandwiches over there. Yep, what's up? Yep, there's some veggie sandwiches over there. Maybe I should have got more vegetarian. I'm sorry. We got five of them. Hopefully that's enough.
By way of audio test, I'll express my regrets for not getting to share in the sandwiches there. I would have loved to be there in person.
Well, thanks for working with us, Hig, and calling in. Really appreciate it.
Yeah.
I might just grab one again. Yeah.
Oh yeah, we're talking now.
Yeah.
We're still underway. Oh, I have my financial goals. I did not exceed them. So my bank is that was my sleeping job. Yeah. I just have a few more years left on this.
We need to.
Yeah. I got had both kids in college.
Oh, okay. It's okay. I wasn't sure if you wanted to, like, yeah, because it has just like some of the basic descriptions and stuff. So yeah. Yeah.
No, sure. You drink?
Yeah. What I'll do is just when we have questions, then I'll go in Google Drive.
Okay. Are you guys ready to get started?
Good over here.
Yeah, what's that? I was like, I wasn't communicating or anything. I was like,
Yeah.
I was just like,
Okay, guys, thank you so much again for coming, and we will go ahead and hand it over to Hig to talk about landslide hazards in Cordova.
Oh, thanks, Erin. Yeah, I've spent a lot of time over the last few years looking around the state and trying to understand what we're facing as far as landslide hazards. And so I hope this will be a useful conversation. I hope it's a step towards more conversations in the future. It's a lot of this is quite preliminary, but yeah, hopefully useful. I'm going to give you just a quick outline to my talk. I'm going to do a little landslides 101 section, and so I'll talk about deep versus shallow landslides, fast and slow landslides, a little bit about mobility, about landslides. Some of them are spread really far. And then about things like tsunamis and landslide dams and such that happen as indirect effects of landslides. And then sort of the question of what causes landslides. So that'll be sort of a little landslides 101. I'm just going to mention a little recap of some workshops we did in other communities. This is maybe partly it'll be a little interesting, but it also gives some sense of how, with the variety of different issues that we're facing out in the state, kind of some of the directions we're going to try to address those. And then I'll get into specific hazards in the Cordova area. And I'll be talking about the Sheridan Lake and some other of the other glacier lakes that are growing uphill of the road there. The Haney Range and landslide risk in that area, shallow rain-induced landslides, and then on a broader scale, where places where you might, or effects you might see from more distant landslide-generated tsunamis in Prince William Sound. So this image shows the aftermath of the landslide that happened in Wrangell in 2023. The kind of gray color here is snow on the ground where it was scraped bare. This is American football field for scale. So you can see it was a pretty big event. It left this big barren area. One arm flowed off in a different direction here. And if we zoom in over here, we can get some kind of tangible scale for that. And so there's a house here. There's actually someone standing on the street. You can see this house. It was really close. There's actually another house that was originally down here in the lower left. And unfortunately, that house was destroyed and the family that lived there died in that landslide. Now, there were surveys done before and after the landslide, before not knowing it would happen, but luckily we had the data, and then there was measurements made afterwards. And what this shows is how much material was, how much soil and such went away. And what you see is the very thickest spots, like right up at the top. Some of these get up to be 15, maybe a little more feet thick. But most of this is quite thin. It's like 10 feet or less, and it kind of was this just thin layer all across the ground. And so this is what we would classically call a shallow landslide. It involves the trees, the roots, the soil, but it doesn't break down into the bedrock. And so as an example of a deep landslide, I wanted to talk a little bit about this landslide that happened down in Southeast Alaska this year in Tracy Arm. And this is actually a model output. You can actually see the waves, the little wind waves on the modeled fjord moving. And actually this gray blob here is a very large landslide that's happening. And it looks like it's going in slow motion. You can see things starting to change. This is actually just because it's very large. And so it kind of looks like slow motion. The upper edge of this landslide was 3,000 feet above sea level. Parts of it were 800 feet thick. It broke down through solid bedrock. This had nothing to do with like loose material on the surface. And it fell very quickly, over 100 miles an hour at its peak speed, into the head of Tracy Arm. And in doing so, produced this large tsunami. Really unusual, extreme event that produced the highest run-up ever observed other than Lituya Bay in 1958. So it actually reached about 1,600 feet, kind of in what is the foreground of this model view. So this is a good example of a deep landslide. Very different beast. It's breaking the bedrock, and that bedrock is falling down the mountain in that landslide. Another big distinction we would make between landslides are slow versus fast landslides. And so this is a couple of slow landslides that are above Portage Lake. Portage Lake could just be off to the right edge of this. And there's two chunks of the mountain that are actively moving. So they're both in motion, as far as we can tell, all the time. They're moving right now. This upper, what we call Portage A landslide, is moving about 10 feet per year, while the other one's moving only an inch per year. Those are really different speeds, but they're both very slow. They're both slow enough that you would never see that anything's going on. So that's an example of a slow landslide. Here's one more. This is this arcuate crack in this mountain up near the Alsek River is evidence that this chunk of rock has moved slowly over time. We don't know exactly how fast, but we know it's been moving for a good part of a century. But in 2021, there was a big rainstorm, and it caused this slow landslide to fail abruptly and become a fast landslide. So it came out of this area here, it flowed down, it was moving fast enough, it banked off the far side of the valley, it went down through the valley, and actually most of the landslide mass ended up right here. And so this is a very, very fast-moving landslide. It actually, these two little lakes that were there before, it pushed all the water out of those lakes and produced a tsunami that flattened the forest in here. It pushed giant boulders out into the Alsek River and actually shifted the river over a bit. So the distinction between slow and fast, we're talking from landslides you can't even see that they're moving to landslides that are moving so fast you might not be able to outrun them. This is also an example of a highly mobile landslide. And so it turns out that it varies a lot how far a landslide moves once it gets going. Unfortunately, the science is not great on this. We can make models produce different amounts of motion, different degrees of mobility. However, we can't do a good job of predicting how much there would be. So if we're looking at a mountain, we say, okay, well, if that fails, it's very, very difficult to predict exactly how mobile it will be. And it's important to remember that not all landslides are like this this one and the Tracy Arm one that were highly mobile. This landslide is one that happened onto Ellsworth Glacier east of Seward in 2022. And the source area is up here. You can see the scar in the mountain. This is just 10 days or so after it failed. And it spread almost half a mile across the glacier, which may seem kind of mobile, but it given how far it fell and how steeply, this is really unusually low runout for heavy bedrock mass like this. Commonly, when you drop all this rock onto a glacier, it actually melts some of the ice and it will flow a long ways down the glacier. But for whatever reason, this one surprised us by being not very mobile. And so that's a good example of a less mobile landslide, despite being one that was moving quite fast. Now, I want to talk a little bit about indirect effects. And so if you want to sound really cool when you're talking to scientists, geologists, you can call them hazard cascades. But basically, this is when a landslide leads to one or more things downstream. And this is a small lake at the head of the Extall River in northern BC. And in 2022, there was a landslide that came down and completely covered that lake and filled the valley around it. So the toe of the landslide is actually down in the right corner, lower right of this image. And you can see some of these rocks would cover a large portion of the football field I'm using as a scale bar. So this is a giant landslide. And I think if you look at this area, it seems like the most important thing that happened here was, oh, there's this huge landslide. It's interesting, though, if we go downstream a little bit, this is about 1.5 miles downstream. And after this is what it looked like before the landslide. And so here it is after the landslide. So even though that lake was pretty small, that was hit by the landslide, it pushed all the water out of it all at once. And so it went raging down the valley and it actually stripped the forest out of this area way beyond where the landslide reached. So no direct landslide impacts happened here. And so you could call this you could refer to this all as a tsunami, as a lake tsunami. Often once they've left a lake and started flowing down the valley, we call it an outburst flood. And sometimes we would specify it's a glacier lake outburst flood. But either way, this is an impact that was kind of separate from the actual landslide itself. I'm putting a fair amount of emphasis on these landslides that generate tsunamis because I'm concerned that this is a growing phenomenon. And one of the data sets that has really convinced me that this is the case is one that I compiled looking at landslide-generated tsunamis throughout Alaska and British Columbia. And so this is just kind of the first compilation I did. You can make some distinctions here. So these big red ones, these are all in Lituya Bay. So it's kind of a unique case. Lituya Bay experienced rapid glacial retreat in the 1700s. It's kind of a different schedule than other ones. These two blue ones are glacier collapse events. You might not even call them landslides, but I would consider them a type of landslide. I also shaded in a few, like in this gray color, to indicate that there were landslides that happened on slopes that had glaciers once, but it was a long time ago. So if we cut out those kind of special cases, we end up with these events that are all pretty close to the present. And as I showed you with some of those previous examples, especially that one in Extal, these tsunamis leave a really clear scar on the landscape. So we expect to be able to see them even if we didn't look at them right away. Let's say, we probably are undercounting the ones in the 1800s, but I actually don't think we're undercounting them by much. And then you see there are a lot of these that have been happening just recently and very few earlier in time. Now, I made this graph in early 2024, I guess, for a presentation. And then shortly after that, there was a landslide in Pedersen Lagoon, west of Seward. And then this year, there was the one in Tracy Arm, which doesn't really fit on this graph. So we're seeing this continued pattern of a lot more of these events happening. This is probably to do with glacial retreat, leaving slopes unstable and then also exposing water directly beneath them. So this is a really growing concern as far as these indirect impacts. And I wanted to show one particular example, this Pedersen event that I mentioned from last year. This landslide happened. It came from here and went into this lagoon. It's actually two lagoons that one above the other in Ayalak Bay. Landslide went in here, created a tsunami that went out this way. And so from a hazard cascade perspective, or from indirect effects, it's quite complicated. So there was, prior to this, a slow landslide that was happening down at the bottom of the slope. I had identified this a few years ago and actually contacted the lodge that's over here, and we had this conversation going about potential concern about landslides and landslide tsunamis. What happened is this creeped along, and then during a big rainstorm last year, the landslide failed up here. And so I call it retrogressive, which just means it's the part behind the moving piece that failed. And when it failed, it turned out it was highly mobile. So it had long run out, went down, all the way down, turned 130 degrees, went into the lagoon, produced a tsunami there. That tsunami traveled the length of the lagoon and then went out. You could call it a flood out here, an outburst flood, or you could still say it's a tsunami. I would tend to call the flood part of the tsunami. And then it formed a tsunami down in this lower lagoon. By this time, it had dissipated quite a bit, but it was still large enough that the tsunami swept underneath occupied guest cabins in the lodge that's right over here. So here's just a view of that path that the landslide followed. And you can see it banked and went around the corner to get into Pedersen Lagoon here. And those effects, so now we're looking up the lagoon. The landslide happened up here in the background, and we're just along the shore here. And this is alder forest that was decimated by the tsunami. And this is about a month after it happened. And here are this is in that area of flooding where the tsunami was about 20 to 25 feet up these trees. And so here are the measured run-up heights. So it actually got a little over 200 feet up the mountainside here. On the lower lagoon, it was much smaller. And this is a pretty important point. These tsunamis are extremely dramatic near the source area, but they do diminish fairly quickly. So if it hadn't diminished so much, it would have been much worse when it arrived at the lodge at the far end. All right, I want to talk a little bit about what causes landslides. Now, if you go and ask a geologist this question, what caused that landslide, then you might get a kind of cheeky answer that gravity caused the landslide. This is probably not the answer you were looking for, but I do want to flag it because it is a reminder that all of the energy that does work in these landslides, it comes from having this mass of material that is up high, and it is gravity pulling that down that actually leads to all the effects we see. However, what I think people are more wanting to know is a little bit more immediate cause, and a lot of people will immediately jump to rain, that rain causes landslides. And this is the right idea. This is correct. Rain is, I'd say, the #1 risk of, or the risk factor for landslides. It's often a trigger for landslides that are small or large. It can be other sources of water. So it can be rapid snow melt. It can even be like a water tank that's underground that breaches and leaks into a slope, can cause a landslide. So any source of water can be a big risk factor. Earthquakes, people know this as well. Most people associate earthquakes and landslides, and this is also a accurate association. Shake things really hard, sometimes they fall down. Something that's really important to consider is changes in the slope. And so this can include processes that undercut a slope, like road building or coastal erosion. It can also include glacial retreat. It's kind of similar to undercutting, but kind of a special case of that because it removes that support from the base of the slope. And additionally, permafrost thaw. So if you have permafrost in a slope, that permafrost can contribute significantly to the strength of that slope. Basically, it freezes the cracks shut. And so if you warm it up, then that permafrost can fail. So if we look at different cases like this Pedersen tsunami, we can kind of look at causes in two ways. The first is, what is the long-term cause, or what is it that preconditioned the slope to fail? And so in this case, the glacier used to fill the lagoon here just a few years ago, about a couple decades ago. It was mostly full. It retreated really rapidly, and then we see this landslide happen after that. So preconditioning by glacial retreat seems like it's a really likely contributor. However, the day that this landslide happened was an extraordinary rain day. It was somewhere between a 10 and 25-year rain event, which is really impressive when you're on the outer coast of the Kenai Peninsula. So we can probably say it was rain triggered. So I'm going to use preconditioning and triggering as two different kinds of cause for any given landslide. So here's another example. So in 2022, there was some rockfall along Low Point Road. This is a loader that was working to clean that up, but you can see he's backing up right now. He senses maybe something's a little off here. You'll see a big boulder come down in a moment. I don't know how well this is coming through with the internet connection. But this was on a blue sky day. It was not raining at all, and it had actually been sunny for quite a while. However, it was in early May, and it was a hot spring, and it had been a really snowy year. And so it's very likely that this landslide was triggered by the rapid snowmelt. And one of the things that I want to point out as we're thinking about that immediate triggering is that probably the building of that road was also a factor. So we undercut this slope with the road, and then rapid snowmelt gave it the water to trigger failure. Perhaps one of the most famous landslides in Alaska history is in 1958 in Lituya Bay. There was a strong earthquake, and immediately following that, a landslide happened in the back of this image here, came down into the bay. It produced a tsunami that swept over this ridge up to, it's like 1,700 feet or something, so a bit higher than Tracy Arm, and then out the bay. And there were 3 vessels in the bay. 2 people died in that event. This one is clearly earthquake triggered, but I'll just jump ahead here. I think it's worth noting that this is an area that experienced rapid glacial retreat. And if you think, well, okay, but really it's still about the earthquake, it's worth knowing that there were landslides in 1936 when there was no earthquake that year, a landslide in 1900. There had been an earthquake the year before, but none that was coincident with that, and one in the mid 1800s. And those other 3 landslides also all were very large, produced tsunamis, and 2 of those 3 actually killed people. So they were really huge events, and they weren't like 1958 associated with an earthquake. So we see that preconditioning, I think, again by glacial retreat that happened in the 1700s. If we look at the case of this Wrangell landslide that I showed earlier, in this case, preconditioning is maybe not that important a part of the story. There's soil weathering going on, so the rock gets weaker over time, over thousands of years. But the main story here is rain and possibly wind triggering. Basically, this was a storm-triggered event. It was right in the middle of a big storm. So seems pretty clear that that was the main risk factor. If instead we talk about this Tracy Arm event, well, there's really good example that it was really good evidence that it was preconditioned by glacial retreat. We see a very close coincidence between the retreat of the glacier and when the landslide happened. Now, a lot of local people initially thought that it was triggered by rainfall because it happened on a rainy day. However, in hindsight, when we look at seismic data, we can see the landslide started progressing towards inevitable failure about 5 days before it happened. So it actually wasn't responding to that rain. It was something that was an internal process, and you could actually see that it had no trigger at all. It was preconditioned, and then it entered the state that inevitably led to catastrophic failure. So we see some pretty big differences in some of these events. Okay, I'll pause here before I talk about community workshops. I just wanted to see if there were any immediate questions anyone wanted to throw out there.
I'm not seeing hands in the room, Hig.
Okay. I'll just keep barreling forward. If someone does want to jump in, that's okay. It's a little harder to do, I realize, doing the whole Zoom thing. So I wanted to share a little bit about community workshops we've done because this has been a situation where we've confronted hazards in a lot of different places, and we actually see some things moving forward. And so these may be models to look at in Cordova, and it may also be that we want to do a more detailed workshop in the future. So the first one that I was really involved in was in Glacier View. I'll talk about that. We also just recently went to Homer and Seward and Yakutat. And so I'll just give a little bit of a reflection from each of these. In Glacier View last year, a little over a year ago, we spent some time, actually had a really great international scientific team coming in and working with locals and people from state and federal agencies. Had a really good conversation, and one of the outcomes of that is that we've actually installed some instruments up above Victory Bible Camp, which sits on below a pretty dangerous slope. These blue dots here are recording the distance between one of these instruments and a reflector as that reflector moves along. And so each of these big ticks is about 4 inches. So since I just swapped the instrument out only about a month ago, and in that time it has moved about 8 inches or so. So it's a pretty fast moving case. So we actually do have some instruments in the field that we can watch there. And that gives us some sense of what's going on. It's kind of nice to see it just moving along steadily, no signs of dramatic changes. In Homer, we had to confront this quite different hazards that really overlap a lot of the community. We have a big deep landslide to the west of Homer that threatens the road and pipeline, and a canyons that are producing shallow landslides to the east of Homer. And so we had some really great discussions, including about the potential to use a model similar to Sitka to confront the shallow landslide hazards. We did a poll at the end, and people talked a little bit about, or reported some of their different thoughts on what they thought would be valuable. You can see a wide variety of different ideas. But when we asked about an important step as far as monitoring, there was a lot of interest in a community-owned monitoring program, which was really interesting to see that. In Seward, one of the big questions we had to face there was the difference between 2 big questions that I often get. people will often ask what's most likely to happen. This landslide that I showed earlier that happened on Lowell Point Road, it's not the first time that's happened there. It's actually happened, I think, at least 3 times. We have every reason to think it might happen again. And so if you're just wondering what's most likely, this gets pretty high on that list. However, if you ask instead a very different question, what's the worst that could happen? The answer is really different. We see Mount Marathon has shifted towards the town. So this line here is a crack in the mountain where part of it is shifted forward. And there's a section of the mountain on the lower right here that's moving right now. So the worst case, or a very bad case anyway, here would be that a chunk of this mountain would fail and actually sweep through downtown Seward. This would be a far worse scenario. It's less likely, but because of its severity, I would say it's worth kind of keeping both these likely and these, near worst case scenarios in mind at the same time. And so we had some great discussions about that. In Yakutat, we focused primarily on one hazard, which is a slope up the bay that there's a danger it would produce a tsunami. And so this is model output from a model by Pat Lynette. He's the same guy who made that Tracy Arm model. And one thing I'd just flag about this is by setting up these kind of interactions between community members and scientists, we actually get some science done because the scientists are engaged, and Pat put this whole model together for this, and it was very helpful in order to understand some of what the hazard was from this particular slope. So with that in mind, I want to go and spend a bit of time talking about what I've seen in my own review of what we know, I guess, about landslide hazards around Cordova. I'm going to start with maybe the funnest example, in that it's not one that I think poses a huge hazard to people, but there was a landslide in, I think in 2023. And in order to kind of see what happened, I want you to focus your eye in on this little area. Hopefully you can see my mouse there. Put a little outline on it next to my little scale bar football field. And so I'm going to flip to another image, and you'll see the shape of the ridge change right in this area. And so you see it gets this arcuate pocket in it here, right? So there's that shift in the shape of the ridge. And so that was a section of the mountain that failed as a landslide onto Goodwin Glacier a couple of years ago. Now, I don't know whether I sort of tricked you by trying to get you to focus on this little detail of the source area, and it's quite surprising to see what happened with that landslide. So that material here fell down, and it turned out into a very mobile landslide and actually flowed most of the way down the glacier. It flowed about 3 miles down the glacier. So that's the outline of the deposit. And so you can see how that chunk of rock really spread out going down the glacier. This is in the same area as Shattered Peak, which produced big landslides, including onto Sherman Glacier in 1964. So we see clear evidence that Cordova does have big landslides, and so hopefully they, as much as possible, stay up in the mountains where they aren't doing too much damage. But I think it's important to know that this is you are in a place that has big landslide hazards. Now, when I think about landslide hazards, I often immediately start looking at the areas that have rapid glacial retreat. And so this is an animation of Scott Glacier retreating over the last I guess it's about 14 years. And what you'll see is that over that time, it starts developing a lake at the front. And the lake has a couple different properties. Let's see, I'm going to try to pause it here. So this lake has a portion where it's just the glacier starting to break up. It also has a portion where it is sediment on top of ice that's melting. And so this process will certainly continue to some extent, and I expect this lake to get bigger. At this point, there's probably not that much concern. There's not that big a lake. There aren't that many slopes above it. You could conceivably have a landslide along this slope that could go in here and produce a flood that would go down the river. But I wanted to flag this in particular because as we look forward towards the next couple decades, we have every reason to think this lake will get a lot bigger. And as it does, it will expose more slopes and there'll be more potential for landslides that could generate tsunamis and consequent floods. Now I'm going to explain this kind of crazy colored figure here, which is kind of raw data. I didn't do a very elaborate processing of this, but and I want to say before I get into explaining what you're looking at is that this is not a very accurate data set. And so I'm going to explain like there's one thing you can get out of this that is really valuable, but you shouldn't take it too literally. And what this is it's an estimate of where the surface of the Earth is underneath the glaciers. And so Scott Glacier is up here. And so this green color refers to an elevation that's right at the toe of the glacier. And what this data set is saying is that it doesn't get, the base of the glacier doesn't get that high again until you go way up here, miles upstream, and similarly out into this side valley, this sort of side glacier. So basically this data set suggests that this lake will grow quite large over time. And actually these polygons here, those are actually old landslide scars. So as it gets back into this area, I would worry about this ridge potentially failing into the lake that's forming. Now, when I say this data set's not very accurate, that's because it gets the actual number quite wrong. It's often way off on exactly where, how deep a given lake will be. It does, though, do a pretty decent job of showing where there are low spots. And so the fact that it shows this low spot that would form a lake, I would give that some credit. Maybe it's going to be wrong about where the upper edge is, but I would expect that they're correct, that there will be a big lake that opens up in here over the next few decades. And we can look down, similar kind of thing at Sheridan, and it shows the lake extending up, several miles further than where it is right now. The ice face is about here right now. And also at Sherman, it shows a long, slender lake that will eventually emerge out from underneath the glacier there. So we kind of expect these areas to develop big glacial lakes in coming years. Of course, Sheridan is well on its way to that. And so here's just another one of these animations looking at Sheridan Glacier over the last again, I think this is the last 14 years or so. And so we see by the end of this animation, you'll see the lake opening up along in this area. We can also go to Sherman Glacier, and this one's really complicated because the toe of the glacier is covered by 1964 landslide from Shattered Peak. And so that landslide is still on top of moving ice. You can actually see quite a bit of motion of the glacier in this area. And you can also see this basin starting to expand here. It's not forming a very big lake yet, but at some point fairly soon, we'll start to see lakes opening up here. And so again, these things are a concern just in that there would be a landslide could go into those lakes and produce a flood downstream. Now, the one of these that I think is a present concern is Sheridan Lake itself. And I'll show a couple reasons for that. One is this Sherman River Delta. So all of that sediment coming from that old landslide is building this delta out very quickly. So over this time period, you'll see this delta forms and pushes out. And as best as we can tell, or as best as I can tell with the data I have, the lake is quite deep. If anyone knows of measurements of the lake depth, I'd love to hear about that. But this delta front is probably quite unstable. My main concern there is not so much that it would produce an enormous flood downstream. Delta front failures are not, they usually don't produce as large a flood as a landslide coming from high on a mountain, but it could produce a damaging tsunami along the shoreline of Sheridan Lake. And so that's a significant risk there. One thing that I didn't actually pick up on until today, there might be people in the room who are like, is Hig going to talk about this spot? This is down at the west corner of Sheridan Lake. And so this is where the access road, I think it's still a road all the way up there, goes into this area. Looks like there must be some campground or something there and some trails. And there is this big crack in the hill slope here, and you can see forest that's below the water level right in this area. I did some other looking around, and this, especially this upper portion, is actively moving, which is a bit worrisome. This mass is not it's not nearly as big, for instance, as that Tracy Arm landslide I showed, and it's actually a lot lower down than that. So the size of tsunami, we're not talking about one of these apocalyptic 1,000-foot tsunami kind of situations. But if this fails, it would create some sort of tsunami, and especially for this area right here next to it, that could be really dangerous. And you could see flooding in the dry, or the mostly dry riverbed from the old Great Glacier river that came out of here before the ice retreated. So this is, I would say, very much on the top of my list of concerns. There are other slopes along Sheridan Lake that also show signs of degradation, including up to the northeast of here. So I guess if I were to just put one thing out there where, if you want to take my advice, I would not camp on Sheridan Lake. And I might visit it. I would probably limit the amount of time I spend along the lake. I would avoid it in rainy periods. Sheridan Lake, I'm now fairly scared of. So, for what it's worth. Yeah, so there's that crack. I wanted to just take a small detour and talk a little bit about signs of this kind of ground deformation that you might see, especially for people who are out hiking around in the mountains. And so this is a crack up above Portage Glacier in that same area I showed some images from before. And so one thing we see is there's a step in elevation. So that's a pretty clear sign of deformation. We also see stretched vegetation across the crack, and we see bare soil, stuff that, with enough rainstorms or vegetation growing, it should be gone, but it's exposed here. And so that's evidence of something deforming in the bedrock that's actually active. And I think my friend Phil here is just being overwhelmingly Alaskan in this photo. But this is another example in that same area of one of these cracks. And I just want to point out this kind of unusual pattern where the part that is up is towards the slope. It's towards Portage Glacier in the background. We call these anti-scarps in that they are facing uphill. And this is actually quite a common pattern. And so looking for steps like this, where as you're going uphill, all of a sudden you step down slightly, that's something to kind of flag as a possible sign of landslide activity, slow landslide activity in this case. All right, so I wanted to spend just a moment noting shallow landslides. I talked to Jill Nicoloso. She was there in Cordova in May, I think, and she pointed me to, I think she heard from locals, maybe someone in the room, about this landslide that happened recently, I think maybe last winter, on the northwest side of Eyak Lake. It's a quite small landslide compared to a lot of what we're talking about, but it's right uphill of the road and the structures here. So this sort of thing, that's what we're talking about, in Wrangell and other really terrible disasters that have happened in Southeast Alaska. Anywhere where you have really steep slopes above where people live, there is a risk of shallow landslides. Those will almost always be triggered by either extreme rain or snow melt. There's some that are triggered by the combination of those two. And so they really are strongly associated with weather. But I definitely don't want to give any implication that these are not an important hazard. There are definitely places in Cordova I would worry about this. And one other area that is a really complicated subject. This is something where a lot of further study is needed, which you can say that about everything that scientists look at, but the Haney Range, the mountains, Mount Shields, and others kind of south of Eyak Lake, this range has a fault, a tectonic fault in it, or maybe two, depending on how you map it. These have not been studied much, but there is some evidence that they are active, meaning that they can still produce earthquakes today. It also has extensive signs of landslides, mostly slow landslides, that are probably associated with those with that fault. That definitely increases the risk of something happening. I would especially point to places like this sort of couloir here with an alluvial fan at the bottom. I think this is an area of snow avalanche danger. it's also a place I would really worry about landslides impacting the road and other structures and stuff in this area. But it's also something that, like, I wish there was more I could point to in terms of geology to understand the risk of earthquakes here, because I do think this is probably something I've worked on earthquakes a bit too. So not only for the sake of worrying about landslides, but just the earthquakes themselves, I do think that more study needed of possible active faults in the Haney Range here. Finally, I wanted to just talk a little bit about the risk that posed by distant landslide tsunamis. So this is a figure from a paper that I was part of a few years ago, where we were looking at the possibility of a Barry Arm landslide and tsunami. The impacts in the immediate area are really severe, maybe looking at hundreds of feet of tsunami run-up, that sort of thing. As you get further away, they get a lot less severe. And so, this figure, the different colors here, it's kind of like the black colors here are far more extreme than anything in these purple colors. And then in the red colors over here, this is just tsunami currents. So it's the motion of the tsunami generating really strong currents. And so it doesn't really have much actual run-up out in the further parts. But that's potentially important to people in Cordova, partly because Cordova is in a place where tsunamis can generate strong currents. So even a tsunami as far away as Barry Arm potentially could create some dangerous currents in the waters off of Cordova, given how constricted and shallow they are. And also, of course, some of you are traveling elsewhere. And so just to give the big picture of what we know about this hazard in Prince William Sound, much of it is in the area of Port Wells. So Passage Canal, Barry Arm, Harriman Fjord, Yale Arm, and Harvard. So all of these places, we see a lot of landslide activity. But there is one spot, my scale bar here covers it up, but in Columbia Fjord, we have a landslide that we've been looking at there that's as of this year entirely above the water. It used to be above the ice just a few years ago, but it's now directly above the water. And so that is, slightly closer to Cordova and definitely closer to other places that potentially would be vulnerable there. We do not know of, there is a little bit of concern maybe up right in the area of Valdez, but as you get more southeast in the Sound, we have not identified any immediate tsunami risk on the ocean here. So this is something that is primarily seems to be a hazard as you go further to the northwest. I think it's really useful to think through what you would do as a vessel operator if you encountered a tsunami. And this is a very wordy slide here, but I just kind of boiled down some of the guidance that I've been involved in assembling in numerous conversations about the risk to vessels. Part of this is inspired by digging through a lot of case studies of different tsunamis that have affected vessels, both landslide and also tectonic tsunamis. So this illustration is this kind of crazy tsunami effect of some sort that happened in 1960 in Chile. And there were two tugboats that were sucked through this big standing wave. One was sucked through backwards with no power and it was lost. And the other one was under power. They were able to steer into it and they actually punched through this wave and the vessel survived. But just to very quickly highlight a few of these things. Before the tsunami, knowing the bathymetry of the area you're in, beyond just the practical implications for navigation, is really useful. The deepest places are vastly safer. A shoal that may not be a hazard for your vessel can be a hazard in a tsunami because you can get tsunami breaking over shoals. So really knowing a bit about the bathymetry can put you in the right place. You might end up in a position where ports are, getting into ports or ashore is really difficult. So you might have to wait a while in the water, avoid anchoring in areas like glacial fjords where there's lots of glacial retreat, where there might well be tsunamis. the Tracy Arm event in particular it really highlighted this. When I was doing field work there a few weeks ago, we worked off of a vessel that had been anchored 24 hours before the tsunami, had been anchored on this shoal in the upper arm, and almost certainly the vessel would have been destroyed if the tsunami had happened then. There was over 100 feet, in one place 300 feet of tsunami run up on the shore right next to it. And the model shows that that place that kind of drew them in to anchor there, it's a relatively shallow place. Well, it led to this huge breaking wave that would have been really, really dangerous. So yeah, flee to deep water. Spread the warning to other vessels. Like it can be even having 2 minutes extra time to respond, but it could be more than that from a VHF call. Could be really valuable if you can. And similarly, like assisting those in need after the tsunami. It's maybe that vessels on the water are some of the most important assistance for vessels that have been damaged by the tsunami. I'm happy to go into this more, but I want to leave time for other stuff. So just to sum up, a few of the things I flagged, really worry about tsunamis on Sheridan Lake. I will say my concern is especially high. Like I said, I wouldn't camp there. It's for smaller tsunamis along the shore. Flooding downstream is a concern, but I see that as a much lower probability than something that could be quite dangerous on the lake. In the future, we might have that concern up at Scott Glacier. We probably have a little time on that one. There is this complexity in the Haney Range with earthquakes and landslides interacting. Shallow landslides are a concern where steep slopes are above where people are, and then tsunami currents would be something you would, even though Cordova isn't near some of the sources that we've identified as really concerning, those currents can affect pretty distant ports. And I queued Kristen up to show a video. It's about a 2-minute video of the Nuugaatsiaq tsunami, or it's the Karat Fjord tsunami that hitting Nuugaatsiaq in Greenland in 2023, I think. I'm starting to get my years confused here. So Kristen, do you want to, it looks like we do have one guest, so I'll go ahead and stop the share. And do you want to pull that one up?
Yes.
We'll just let it start playing, and then I'll kind of explain what it is that has led me to show this video quite a few times. So I think, I grew up here in Soldovia where I live, spent a lot of time on the beach, messing around with boats, dealing with different problems that come up. And so when I look at this, I feel like I can just get right inside the heads of these guys who are like really worried about their boats as this wave comes in. And you'll see them going down and messing around with ropes and stuff. So I hope that I'm imagining that's kind of a shared experience for other people in the room, that you've been around beaches and boats a lot and can imagine what these people are going through as they try to figure out what to do. I'd also point out in the background, that dark spot there is actually another boat, and they actually ride out this whole event quite with no problem at all, sitting out there in the ice in deeper water. But what we see here is a series of fairly short period waves, and this is something that landslide tsunamis often do, is they produce waves that come and go much more quickly than tectonic tsunamis, and can get very complex. And so in this case, there was very little protection between the community and this tsunami. And unfortunately, 4 people died in the community. As far as I can tell, this person did survive, though you see the water splash around them. But I'm hoping that since we got to see their video, that means they did survive. It's something that I often see in eyewitness videos of tsunamis is that. Here, I'm trying to share my screen again and talk at the same time and failing. But is that it sneaks up on you. You see something strange going on. And then by the time that there's, by the time it's apparent that things are bad, it maybe not too late. Often when you have an eyewitness video, it's someone who survived, but it's a much shorter, much closer call than maybe they were looking for. So I'll just end there. And I know we don't have a lot of time for questions, but I am very happy to take any questions that come up.
Yeah, go ahead and.
I got a quick one. Thanks for the presentation. That was awesome. Is there, maybe I missed it, but is there a seasonal component to this? Looking at your map of Sheridan, for instance, I mean, there's times when there's 50 more people and kids and everything right in that corner that you're talking about to ice skate, and so it makes me wonder, are these things more likely in the unfrozen period than they are in winter lockdown, or is there any evidence there to speak to that?
Yeah. So I think your intuition is good there. Yeah, if it's like the exact time nobody would want to be out there when it's raining buckets, that's probably some of the highest probability. So that's good news. We do unfortunately sometimes see landslides that really don't line up so well with what you expect. So it's more likely when there's a lot of rain or rapid snowmelt. So it could be a beautiful spring day like that Low Point landslide. But it can happen at any time. How much that probability varies is something I would like to be able to pin down more. I think it's a lot. I think that most of these landslides are happening when there is some direct external factor, like really heavy rain, rapid snowmelt, maybe an earthquake. But there are a few exceptions to that. The earthquake is also something to flag there, right? Earthquake doesn't care what the weather is, so and doesn't give you a lot of forewarning.
Go ahead.
You mentioned currents in the, if there's some happening in Barry Arm, we see currents in the bay out here at Cordova. But would currents have to be 2 knots, 3 knots, 10 knots? When you say currents, what are you talking about?
Yeah, so it gets really specific, but you can see currents that are that get up to way beyond what you would see with normal tidal currents and such. So you can get 10 knots. I'm not saying specifically that would necessarily happen with a Barry Arm landslide in front of Cordova, but what I would say is that let's see, a couple things. So one is that if maybe you do get that radio call where someone says, oh, there's a tsunami that was just triggered and it's somewhere far away, but you're close enough that you're concerned. Getting away from narrow constrictions and stuff, just the places where you would expect a strong current could be generated, that could be a really good idea. One thing that's a little tricky is that sometimes these tsunamis, as they pass, they produce whirlpools, they produce big horizontal eddies that can be really persistent, first of all. They can last for hours after the tsunami, and they often produce some of the strongest currents, and they can drift around. So they can really kind of catch you off guard in the wake of a tsunami. And we see a lot of evidence of this just through really detailed modeling, but there are documented cases, especially in harbors. So, especially the places that are normally most protected, they tend to spawn these big rotating currents that can be hazardous.
Go ahead.
I had a question about was it the Pedersen Glacier that had the lodge in the lagoon? How does that conversation go when you've identified a risk and somebody in the path of the risk? Do you talk about mitigation strategies or, potentially sell it up, move it out?
Well, it's an interesting question. Well, so just to that one specifically, the reason I was talking to them initially before this event happened was that I'd identified that creeping slope, and also there had been a tsunami that happened in the spring of 2022. It wasn't as big, but if someone had been camping up in the upper lagoon, they would have been in bad trouble. And so that's kind of two big risk factors coming together. So I got in touch and we discussed the possibility of monitoring, and kind of looking for signs such as increasing deformation. It was a fairly early, conversation, and I think everyone, including me, was just hoping we could, kind of ponder it for a while. And then last year, this event happened. So they called me just a few hours afterwards, and we're like, yeah, we don't. They couldn't see it at that point, so they just knew that their, boardwalks had gotten ransacked and something had happened. But they immediately jumped to the idea that this might have been a landslide-generated tsunami from the upper lagoon. And we're still in that conversation about potentially doing monitoring. It's not easy, but it's a pretty attractive solution in some ways, because these slopes, if you have some sort of instrument there, often you will see that they speed up before they fail, and that can actually give you not like 100%, for sure warning, but it can give you a clue that it might be increasing risk for even months before. And in a few cases, you see very distinctive acceleration that, in the days and hours before failure, it's not 100% sure it's going to fail, but it looks really likely. And so you could take strong action to evacuate or whatever based on that information. So that's really attractive. Now, of course, one thing that's really not attractive, but I think it is part of the spread of things to consider, is to completely abandon a site and, say, well, okay, the risk here is really high, and we've invested in this place, but, we're not willing to continue to be, to face that risk. Yeah, that's, I guess my perspective on all of this is that I want to provide useful information, accurate information, and I think that the things that people, I guess the progress that's made to reduce the consequences of this sort of event, ultimately that's going to be led by whoever is there facing it. I think even more so for landslides than for other things, because we have very little in the way of sort of a larger agency structures or anything. Landslides are something we don't have the equivalent of the Alaska Volcano Observatory for landslides. So it ends up being kind of, I guess the good news is it's up to people who are, at risk. There's no governments that come in and tell you have to leave or whatever. But the bad news is that means that responsibility falls very heavily on the shoulders of those who are actually facing this. And there isn't easy answers in many cases.
Go ahead.
Hey, thanks a lot. And a couple of things following right up on that unit that you showed in Portage Lake, watching its movement looked pretty simple. Do you have any idea how much something like that costs to get and maintain, for like in that corner of Sheridan Lake?
So this is my own little passion project here. So I'll try to keep it short, but the backstory is that I initially came into this stuff as a geologist, and I thought, okay, if I identify something, I'll tell someone who knows what to do about it, and then they'll start monitoring it. And eventually realized that isn't the case. Like, there just isn't anyone who's out there ready to step in and monitor this, unless you have boatloads of money and want to give it to a pretty high-end like company that normally serves mining companies or something like that. So I've been trying to develop something lower cost and that local communities could own and maintain themselves, and exactly with what the sort of case that you're talking about. And so that's what I showed a picture of there. The raw cost of actually the components is probably a little over $100. When you put some labor in there, it gets up to around $300. That's definitely not a profit margin or anything, but I'm not actually going for a profit on this. We've got two networks of them out there, operating, one at Portage and one up at Glacier View. We're hoping they'll survive the winter, and we'll learn what we learn from that. So still very much a prototype, but I'm really interested in that conversation.
Nice, yeah, great to have a prototype here. The other thing, you had touched on the Sherman Delta in the Sheridan Lake. And then that was it as far as large deltas. And in turn, their possibility of collapsing into deeper water, like in Valdez or Whittier in the 64 earthquake. And then north of Cordova here, you've got at the very north end in Nelson Bay, a huge delta that slopes down into deep water. Didn't speak to any of those kind of threats, but.
Yeah, I think,
Would you-
that I think that your description of what, what to look for as far as basic risk factors is exactly that, a big rapidly built delta into deep water. I have not looked at that delta in particular. Actually, unfortunately, the people who've done the most work on this hazard, on delta front collapse in particular, are people like Peter Heusler, who retired recently from the USGS. We don't actually have a lot of sort of scientific expertise and effort going into delta front failure tsunamis right now. And I think that it's an important topic. I'd be happy to talk further about that one, but I need to look at it a little closer.
See, I saw your hand first, actually. So you.
Hey, this is a really interesting talk, and I appreciate you guys talking to us in Cordova and being part of this. I can't stay for the workshop, so I think I might be really jumping ahead with my question. It sounds like you guys are going to apply for some NSF funding to beef up this project, which is really exciting. My question is, do you have any insider information whether or not the polar programs are going to exist in July, or if NSF is going to exist in July? I know they're shutting down, like they just are in the process of shutting down the some of the tsunami warning centers in the state. Is there other funding that you guys might go for this?
So no, I don't have any secret insider information or ability to predict what the current federal administration will do. The polar program has survived some of the cutting, and so maybe that's partly motivated by an interest in, great power politics in the Arctic Ocean or something like that. But yeah, predicting that is really difficult. I guess what I can say as far as what we have going into these proposals, we have this one opportunity that is all lined up right in front of us. And, in the normal times, I would say it's a really good opportunity. It's now full of all this uncertainty. But what we are seeing is a lot of scientists, and I would, include Chris and Tim there in the room in this, who have put a lot of energy in already and are planning to pour more energy into writing proposals and getting those out there. My hope is that we'll be successful. Failing that, I hope that we have this body of proposals that do a really good job of outlining what the problem is and what it would take to address that problem, so that as we move forward, we can find some place to bring that need and actually make some progress.
If I could jump in really
Yeah.
quick and just kind of explain that a little bit after, I was going to talk about this after the question and answer, but I'll just kind of couch this now. This is funded, these community visits and these community workshops that we're doing are actually funded by NSF it's part of their large proposal. What is it called? LPS, large proposal support. Thank you. That it's basically to try to get more community involvement and outreach in the development of some of these research questions. Once we, we're going into communities, talking with folks about some of these risks and trying to co-create some of these research questions that we could incorporate into these proposals. Afterwards, because we have this planning grant, this is essentially a planning grant for these NSF proposals, we are able to apply for, multiple grants under kind of an umbrella. And it might be, and there's a larger bucket of funding that we're able to apply for than a typical NSF grant. That doesn't answer any of those questions about uncertainty.
Well, hopefully they,
following kind of the sunk cost idea of like, oh, well, this
Mhm.
program's already underway. Why would we stop it now? That'd be a waste of money if we stopped
Mhm.
it.
And we were
Yeah.
actually talking a bit about this earlier too. Oh, God.
Yeah, so for those of you that I haven't met, my name is Kristen Tim. I'm a social scientist from University of Alaska Fairbanks that's part of this project. But one thing I will say, or one optimistic indication is that the Trump administration has not released a lot of information about their science priorities, but they did release a memo probably 2 months ago or so. And a couple things that I think make me optimistic is just that like public safety around natural disasters, natural hazards was a specific piece of that. And the polar or the Arctic region is another piece of that. And so although we might not consider ourselves part of the Arctic, I think, depending on which definition you're going with, a lot of Alaska can be included. And so those are a couple reasons to be optimistic that this work still aligns with some of the priorities of the administration.
So when you were looking at hazards around the Cordova area, did you look at that area around Nelson Bay? You have relatively deep water with some mountains with very steep rock up at the very top of them. Is that something you looked at and were not concerned with?
Well, I'm very creative. I can always come up with reasons to worry about anything. So it's hard for me to like axe anything off a list. I do think rapid delta build out, that's totally a risk factor. The main things that I've been able to identify with the information I have, which is not everything, right? I have whatever I can put my hands on, not the right data in every case. Are some signs of landslide activity further up the valley. And that hopefully those are not too much of a direct threat unless there are people actually traveling up into the upper parts of those valleys. And those are areas where there's more recent glacial change. Identifying hazardous slopes, LiDAR is super useful. And we do have this, this LiDAR that's been flown right over Cordova, but I don't think it quite extends to there if I'm recalling correctly. And anywhere where you see those super steep slopes above deep water, I would like to have really good LiDAR. So this is this surface mapping, this laser surface mapping. I would like to have really good LiDAR to look at to reassure myself that there isn't something obviously going on there. Overall, if you're looking at slopes where you don't have permafrost and where you don't have a glacier retreating, the likelihood of even steep slopes failing on the scale where they could produce a tsunami is vastly lower. It is, probably at least 100 times lower than the same steepness of slope that is in these areas of permafrost thaw or of glacial retreat. So that does lead me to prioritize those places where that active change is going on right now.
One of the purposes of this workshop, though, is to kind of get some of, if there's places that maybe we should take a second look at, that's good information to have.
Definitely agree. Yeah. And I mean, I think in general, so this kind of connects through to both these questions about specific hazards, but also to what Kristen was laying out and Aaron, as far as this proposal process. When we talk about, communities taking leadership on this stuff, I've now been around this enough, and coming from a coastal Alaska community myself, like it's huge. It really is. It's hard to articulate just how big a deal it is, what people bring to the table from local communities. I think it ranges all the way from those immediate statements about, hey, there's a delta here, let's take a look at that. Like, hopefully, if I'd done a little more systematic looking, which it hasn't been systematic enough yet, I would have picked up on that. But you guys can direct our eyes really effectively in that way. But it also extends to what kind of things can we actually do to effectively address these hazards. And I think that is very, very, it's very important that be led by locals, not just to sound good, but like that's actually how you see something effective happen, in my opinion. So So yeah, I really encourage those of you in the room to feel like, this is not a situation where I have all the information and I'm just giving it to you. This is a situation where I'm looking for, and I think I can speak for my team here. I'm looking for guidance on how to spend our effort.
Any other questions? Yeah, go ahead.
All these avalanches are on very steep slopes.
Mm.
Do you see, maybe they don't cause as much damage, but on a lesser degree of a slope?
So I'd say steepness is absolutely a huge risk factor, especially for the worst cases. So, if we're talking about generating a tsunami, if I don't know anything else about a place, then I'm going to be looking around for the steepest slopes first as places of concern. The kind of the most extreme example of not steep but still potentially a hazard is what are called lateral spread landslides. So these typically only happen during earthquakes, or almost always it's related to earthquake liquefaction, and you can actually have like sediment that is pretty flat flow towards whatever slightly lower spot there is nearby. And so in 1964, this destroyed a lot of bridges because the sediment on both sides of a river would flow towards the river and shorten the bridge and cause the bridge to buckle. So there are things like this that, kind of are in that low angle category. But mostly if you look around, see the steep slopes, you're looking in the right direction to try to identify where there are hazards.
Thank you.
Anyone else? Okay, it looks like no other questions in the room. We did, as Hig mentioned, one of our goals with this work is to come up with, co-create some research questions with the goal of developing some research proposals around these hazards. Specifically, in Cordova, what can we monitor? What do you want to know about potential landslides and potential tsunamis? Where are good places to consider this monitoring, or for us to, do some more research and dig in a little bit more. Hearing about Nelson Bay, for example, is great. And I think that we'll, go back and take a second look at that and make sure that, Hig's kind of initial glance over of that is, what does that look like potentially? And we also want to know kind of how do we best communicate this? These are some questions that we have about communicating this risk. It's very easy if you're in town and your phone buzzes that there's a tsunami risk that but we're talking about large geographies, and we're talking about people who might be out on boats and out of cell phone service. And so as we think about communicating, well, both post-event but also pre-event, how do we let people know about this risk? These are, as Hig said, these aren't, these risks exist. These are very, but they aren't, they're very low probability events, but they could happen. And so thinking about them, considering them, how do we mitigate and how do we prepare so that if they do happen, we know how to communicate and get the word out and people know what to do. So I think what we might actually do, we were originally going to do breakout groups, but I think for the sake of time, we might just kind of do this a little bit different. And I'm thinking as a group, maybe we could talk a little bit. I've heard some of this come up, but talk a little bit about research questions. What do you want to know about these? Where should we be monitoring? Well, I think that's actually the next question we'll ask, but what do you want to know about these landslides and what would be useful to Cordova to know about them?
I think that Haney Ridge weak spot that you pointed out would be a higher priority for the community because of the potential of that to run off into Eac Lake and cause even significant changes in the water level and on the shoreline could do damage to the plant behaviors.
Yeah, definitely. Just understanding more about those dynamics.
Yeah.
Cool.
And I think that runoff, I couldn't tell on the map, but that runoff that he showed, that's where the killer avalanche was.
I think so. Yeah, exactly. It looks like that spot.
Right.
I think it's
So that whole flatland there is there because the mountain wouldn't hold rock let alone snow,
Mhm.
which is a mirror image of, say, what Shepherd Point is up in Nelson Bay.
Yeah,
And don't you also have increased risk for future failures because of the removal of vegetation? Or is that not a component in that situation?
I would leave that to the expert, but I would think so.
Do you want me to jump in there?
Would you mind?
Sure. Yeah. So there are definitely cases where vegetation loss it greatly increases risk of shallow landslides, especially like rain-induced landslides. So, for instance, something that's not so common in Cordova, but if you have wildfires, then that can really increase the risk a lot of landslides during rainstorms. I think, if you have big old growth forests and trees get cut down, we definitely see an association with that and soil failures, and shallow landslides. So there are some cases like that. The worst events where you actually have bedrock failing, they're much less sensitive to what's going on the surface. They're deeper failures. They don't necessarily, it doesn't matter as much what's going on as far as vegetation.
Other thoughts about, what do you want to know about these?
I guess the same thing I had the question on earlier, is that
Seasonality.
at Sheridan, certainly that's, it just is a real recreational hub of Cordova. There's guided kayak tours and pack raft tours, and as soon as it freezes up, people are out there skating around the bergs and, that kind of stuff. There are some huge detached blocks up there. The old Sheridan Mountain Trail goes right by that, that big chunk that's detaching, and, you could look down there and there's, it's a clearly moving, clearly active, and it would be interesting to know, how rapidly that is moving there.
Yeah, definitely.
And then I guess another spot that I'm interested in is kind of north of Crater Lake there. There's a peak like 2310. It's where the radio towers are. On the side that fronts Orca Inlet, which is essentially right above Orca Cannery, there's also just some huge detached, I don't know if it's one of these anti-scarps or I can't remember what you called it earlier on, but clearly there's the whole mountainside there is definitely moving, and you can look down some of these cracks and throw pebbles in them, and it's like, oh wow, that's huge there for sure. So that's another one. There's been a lot of discussion about Crater Lake hydropower and putting a dam, at Crater Lake there, and so I don't know if that's already been investigated. It's all clear or what, but that's another spot that would be interesting to know if that's actively moving, because it is, several thousand feet up above Orca Inlet there.
And putting infrastructure up there, definitely. Something to
It does
consider.
rain here occasionally, and
Oh, it does? I noticed.
yeah.
A spot I'm curious about is, at the base of Ski Hill, parallel with Lake Avenue. I've heard a lot that more recently that land is moving there, and there's a lot of, people that live right there. Parallel with Lake Ave, like, the house was up by, like, on this side of Ski Hill.
Like behind those north kind of.
Yeah.
Like the same slope essentially that failed on the Crater Lake. trip.
Exactly.
Same.
Yeah, it's closer to town where people live.
Yeah, we brought these nice maps, but we're a little too finely detailed now for that, so I'm just kind of making some notes. Yeah,
Yeah, big old dam. You can see it if you just drive to the other side of the lake and look across from from the highway. You go over to Bays Island.
Oh, okay.
Very clear.
Oh, when did that happen?
It happened last winter, right? Yeah.
Look at the highways.
Yeah, I mean, it was one of those, we had some just crazy events.
We were just out at Bold Valley, the east side of Sheridan Lake all day. Yeah, it's both sides of that lake get recreated.
yeah.
Yeah.
I guess another thing about Sheridan there is, that even during just regular high water, I mean, we're really stressing that Sheridan River Bridge. That thing is, whew, at times it's just scary, and DOT is always trying to keep logs, pulled out from it or whatever. And so if there is increased risk of tsunami or something going on in the lake, I certainly think the highway there is clearly an additional risk, just because even right now it's, it's not gonna last forever. And the river is rerouted a little bit, and it's just barreling right at it now. And having talked to some of the DOT bridge engineers, it's certainly a larger concern, so.
Well, just west of it, that's washed out before too. And then upriver, it's changed course. John Gorse Road, it's been quite an amazing amount of real estate out there. The trees coming down. Just
Off a lot of trails and, forest easement road there, and all sorts of stuff.
they're talking about putting a gazebo or something there. At the east side of Sheridan Lake.
There was some of those. They got into Camden money, and that was one of the ideas, that was one of the locations identified. I believe all of that. If we had, additional money for like 26 cabins on South Central, Forest Service, but I think that's all gone.
We're talking about putting an access road from on to, we call it Boulder Alley.
Yeah, they're gonna talk about doing that road.
So, I mean, good access is more open for.
Yeah, that's all. That was right on the verge of actually happening, and some of that got surveyed, and we're doing this now on fire for redoing it.
Yeah, on the east side of Sheridan.
With the funding situation.
Present administration.
I'm curious what the, tsunami potential is associated with that Root River Delta or a landslide into Nelson Bay. I don't know if there's a risk further to the west. I wouldn't think Simpson, Sheep, Ravina.
Yeah, if you guys want to get up and look at these maps.
Nelson Bay is our closest deep water, so it's the generating force of something that could impact us with those steep sides.
Definitely. Well, no,
If you look up some of those slopes way up ahead of Sheep Bay. Someday that's coming down, but those kind of risks are everywhere.
Eric, I'm gonna take it a different direction really quick.
Yeah.
So like along with like glacial outburst floods and tsunamis, like the impact that it can have with the resources on the shorelines in Prince William Sound.
Yeah, absolutely.
Was that a question about the kind of the kind of coastal damage from like more like coastal erosion from tsunamis?
Kind of like, coastal erosion, tsunamis, lake outburst floods, the environmental impacts that can be created in the area and what the risk level is, towards archaeological resources and cultural resources in Prince William Sound.
Yeah. I think that's a really important one, kind of mapping those and understanding.
Yeah, exactly.
Yeah. And also even, thinking about subsistence foods and modern cultural resources that we access and depend on.
From what I've seen in other places with tsunamis, I think that impacts to salmon habitat, potentially long-term positive, but definitely everything's negative when you happens, right at the immediate time scale. But I think that's a real complex topic that's worth digging into more. I think it's not something that's really well studied. And I would think Cordova would be a place where that question would come up in a lot of different ways. I haven't seen a lot of cases where, like, tsunamis are sometimes, if you're right in where they're the biggest, they're very erosive. But when you get to the more distant places, they actually don't do as much eroding as you might expect. And so I haven't seen a lot of cases where that sort of erosional processes the main impact.
I am thinking things though, like, yellow cedar stands. There's a few isolated ones that are important, and something like that could be, depending on where they're located in the geology, could be really vulnerable to a tsunami.
Also kind of curious about indirect impacts. You were mentioning the landslides onto the glaciers that are occurring essentially up the Rude River Valley, north of the Sheridan and all of that. There's a fair amount of rock getting dropped on glaciers that's going to be working its way down. How does that affect those, when it does hit the ocean, how stable those deltas are?
Rapid.
It's very
Rapid sediment input definitely can have downstream effects. I think the Sherman Delta, the rate at which it's building out is really extraordinary, and I think it's in large part probably because of all of that material from 1964 that's dumped onto the glacier. So yeah, I think that that makes a lot of sense.
Yeah, that's a crazy one. I kayaked over to the cliff on the edge of it 10 years ago, and then this year I walked over there. So that's weird. Yeah.
Wow.
Yeah, we could ride our four-wheelers and stuff. We went over to the east side of Sheridan. He got down so far in the marine, the water levels got shallow enough you could just ride across where fuel not really was too deep. But yeah, he got put over there.
Another spot that's changing pretty quickly is Miles Glacier. It's more remote and will affect less people, but that glacier is retreating like quarter-mile season. The lake's getting bigger, and there's big steep slopes that are becoming more and more exposed. And that would have impacts to the moon up in the sonar campus there. And maybe if it was big enough, 27 and 36-mile bridges.
That's actually a really good point. That $1 Million Bridge, has a lot of, just because of when it was built, it has a lot of contaminants in it. And honestly, if it collapsed into the river, it'd probably be something we'd have to do a emergency kind of environmental cleanup on, or we'd at least try to get that done.
Yeah, I could see a scenario that would. I could see a scenario that would threaten the bridge from Miles Lake. Miles Lake definitely has active slopes above it, and I think it's totally within the realm of possibility that there'd be a tsunami there. Fair chance it wouldn't be enough to take that bridge out unless there's some. It's super vulnerable, but still, yeah, definitely. I think good logic there.
What would be the practicality of potentially seeing something installed on that slope that's actually moving at that southwest corner of Sheridan Lake, recreation area?
I mean, I think that even without this NPS proposal, that might be something that Hig and I can have an ongoing conversation about using at least one of his low-cost ones in the meantime to monitor that. I have some funding through the Indian General Assistance Program that goes towards glacier research. And so I think it would be, we could probably write something up, get approval to put some monitoring equipment in there and do that. I think that would be a great idea. I actually didn't realize, like looking at it from above, you see it and you're like, oh yeah, that's a landslide. But that's the first that I really noticed that too. But yeah, let's Hig, separate from this, let's have a conversation about that.
There is a very analog, I guess, landslide movement thing up there. Years ago, somebody put a big hammock over the crack. It's now torn apart, and so it is an interesting indicator, like, oh, this is definitely moving.
There we go, the hammock test.
So it's like, if you don't have any money at all, we can just get a rope.
a guitar tuner up there. I plug it every year. Nope.
Ooh, that's getting higher, yeah.
Yeah.
I mean, those are very practical ways to search.
Mhm,
Of that.
mhm.
And is there ways too that, like, thinking, like, hey, do you need a ride out there? Stuff like that, but cost, stuff like that.
Mhm. Yeah, definitely. I think that's again, with Native Village of Eak, we kind of got involved in this because of questions about salmon habitat, honestly. But also, just kind of knowing about Berry Arm and that risk and trying to understand a little bit more of what kind of risk that might pose. That was 4 years ago, that was announced 5 years ago. But trying to understand a little bit more what kind of risk that might pose to fishermen is kind of what led down this. It's very fisheries oriented originally. But yeah, I think that, we definitely can find some funding for this. And I just lost my train of thought. I'm sorry.
We were just up there yesterday, day before, and there was an eagle sitting out on one of the icebergs in the lake. So I think there's soldiers up in there.
Oh, wow.
I mean, there's gotta be something for them to be there.
Yeah. Wow.
So, yeah.
But yeah, we have some equipment with an NVE that we can use to get out there, and that's definitely some of our, we'd like to get involved with some of this monitoring because it's important and it impacts our land. So, and we also, part of this whole, this proposal building process is we want to invite people from communities that, to collaborate with us, whether it be joining in partners on some of these proposals that we're developing, or being collaborators who might be able to offer, at cost gas rides, things like that, or people that have the time to, volunteer to maybe monitor or check some of these things occasionally, stuff like that. So, there's all kinds of variety of, I think, involvement that we could see coming from different communities, and that's, we kind of wanted to introduce this project to Cordova and see how much people are interested. We are having a proposal writing workshop to really hone in on these research questions. Well, I think we're going to hone in on them a little bit beforehand, but really get to the meat of the research questions and know what we want to put in for these research proposals. February 24th to 25th, is that the?
I think so.
Yeah, in February. And we have been talking, if folks are interested, there's the Cordova Science Symposium that's happening the week before, I think 2 weeks before that, here in Cordova. Maybe having a more in-depth workshop at that time too, with some of the researchers that'll be here.
We've been naming all the local lakes except Saddlebag, which seems to be a good sized lake with some really steep sides. Yeah. Is recognize that would be changing a river kind of direction, but if you got a big enough tsunami coming out of that valley.
26 mile or something.
26 mile, thank you.
Yeah.
I'm not quite sure what that one is.
So something like
Right before the culvert.
125 miles.
It'd be one of the bigger lakes that you can find on that.
I got too many notes here.
I've been keeping detailed notes
Okay,
too.
thank you.
Yeah.
Okay, I see Sheridan. I don't see the lake name. I think it might be.
Yeah, I'm looking at it here.
Okay.
It does have some
There's
super
Sheridan.
steep.
Oh, I see it. Saddlebag Glacier. My eyes are getting old.
Yeah. But it has all that, recent deglaciarization, steep sides. I don't know how deep the lake is, but there's a lot of water available.
Yeah, if you drop a mountain in it, it doesn't have to be a tremendously deep lake for it to create a pretty severe outburst flood. So, that's certainly a big enough lake to be a concern if something happened. How much activity is there downstream of that lake?
There's a trail to the end of the lake that's, before Service Maintained Trail, so it's probably the best mountain bike trail in Cordova, so, it does see a bit of use, but not nearly as much as Sheridan, I would say. I miss the berries, if they went, yeah. I see.
Any other thoughts about questions, locations? Communication, maybe let's kind of ask you guys directly, how do you think it's best to talk about these and get information out about, risks both before they're happening and if there's an event?
You were talking about notifying the boats that are out. How do they spread the word for service? There's a network in place for that.
I'll talk to Kelsey at CDFU. She has everybody's email and information from her for SERS.
So CDFU might, for Cordova, be a kind of a good partner to talk to about communicating with fishermen.
Mm-hmm.
An organization with a lot of.
I'm not at all promoting it or anything, but this town seems to run on Facebook. So. Or put it on the Cordova Classifieds for free and
There has been some talk at some of the other workshops we've had, kind of almost modeling, a warning system after like the avalanche, except that's, such a built out and well-established and kind of there's the science, snow science is really well understood compared to landslide science, but kind of, some an informal network with people that know what to look for and can provide some warning of signs in combination with monitoring. And Facebook is always a great way to get info out.
I'm at Echoes Elementary. Get over there. And I went to the science center. We're fortunate to have them come visit us all the time. And they did a little presentation where the kids could kind of do, I think it was the oil spill. Like if they did like a landslide, kind of look for stake table, I think then they could spread the word to their parents.
Yeah.
Especially those that are new in town. I know several of my students aren't maybe from here and don't know all of it.
Yeah, and I think that's such an important point, like knowing the risk and understanding what to look out for if an event happens.
We're talking about all this, and I'm feeling a little bit anxious about some of this stuff. There's a lot of places I play. It causes anxiety. You said that you said you were in social services or something. Maybe that might be part of the. Going to talk about this. Maybe a little more your field.
Yeah, definitely. I've been chatting a bit with some of the folks who have been working on some of the landslide dashboards down in Southeast around Sitka, and they're working on some dashboards around Prince of Wales Island. And my team has been really active in working with the scientists who are trying to communicate about the glacier outburst flood in Juneau. And one of the things that we're really trying to do is just always pair any information about the risk with something that you can do, because that helps in our minds, help us know what to do, but also feel like there's some sense of agency. And then the other thing with the glacier outburst flood is just making sure that there's kind of a clear delineation between the situations when there's like an emergency and an event versus this like longer term monitoring, because we don't want people to go to the wrong place for information. Like, for example, if there's something happening, we don't want them going to like the dashboard that's monitoring like the slow change. And so just making sure people really know like where to be going, because we don't want to create more pollution in the communication environment. So I really appreciate that comment. It's definitely something that we're working on from the social science perspective. And
They do look at natural disasters.
Yeah.
I would just say, follow up on that anxiety piece. It is real. So I work for Fish and Game, and every year we hire 2 new technicians to go out and spend all summer at Cocktail Camp, and we go out there and put the weir in. We go out there and take the weir out, And the last 2 summers, I mean, it is the topic of conversation out there. Like, okay, we're gonna climb the tree and camp, or what are we gonna, you know?
Yeah.
And the people who are applying for those jobs, they hear about that, oh, wow, I didn't know, is this tsunami risk? As an agency, we have no idea, you know, we don't. So like, yeah, we're gonna hire you and you're gonna be out here, you know, so.
On your flavor.
Yeah. Well, and it sounds like, you know, just like agencies in particular, making sure that they have information, you know, whether it's the Forest Service and looking at recreation, you know, like, or making decisions about where to have monitoring efforts, like those sound like a subset of groups that we could maybe be specifically communicating with to kind of match what we're learning with the needs. Yeah.
There's so many avenues to communicate, but the biggest problem, I think, is that people have to be paying attention.
Yeah.
They're not paying attention, you know, you're just gonna have, you know, below 50% with all these different avenues we have now. You know, maybe 30% really easy to get, but the rest of them, people aren't paying attention, and it's just almost impossible to get information that they will take in.
Mhm.
Can be
It's
tough.
tough,
Yeah.
it's really tough. It's also, as far as communicating during an event, like on a boat with radios, satellite units, and all kinds of communication options now. It's up to that person, whether they're in a kayak or a big boat, what they're gonna have,
Mhm.
and it's their concept of the threat then
Mhm.
as to what they're gonna have with them, and whether they use it or turn it on or not, it's an individual thing. It's kind of hard to get all this kind of stuff too.
Yeah, I think you point on are talking about a really important topic, but this is kind of about also, you know, especially with the monitoring piece, you know, and some of the uncertainty we have around, you know, what triggers landslides and when they're gonna happen. This is more of a risk awareness communication at this point.
Bumper sticker meme I saw a while back. So if you're not outraged, you're not paying attention.
I wanted to jump in and just highlight, you know, that there's mention of, I can hear part of what's going on, but the people who are in camps out, you know, doing work in the field. And I think it's a really, really important place to look at, because your, you know, exposure is proportional to the time you spend out there. Someone who's visiting for an hour spends, you know, just way less likely to be in trouble than someone who's camped there for a month. And it's also your vulnerability is much greater than when you're asleep. And also, if you're out there camping, you're probably going to be through those bad events where the likelihood increases. You'll be actually out there when it's raining and that sort of thing. So I think it's you know, in terms of reducing exposure, you know, having really serious conversations about where those camps are sited is very important.
Mhm.
No, I think of just the conversation this evening about the Sheridan area, you know, has created a level of concern. And it's okay, so if you just say, hey, this is a, you know, a fairly high risk, and leave it at that, I don't think it's helping.
Yeah. Yeah.
Because people, you know, it's okay, well, it didn't happen today. It didn't happen today, and pretty soon it's gonna be forgotten. You know, I keep thinking, okay, is there something that, if there was a sign there that I actually read, the whole sign, and it said, hey, here's the risk. Watch for these major signs to tell you it's time to leave now. You know, tsunamis, hey, if I see the water going out really fast, I'm running uphill. I've learned that much. You know, but what are those things with the landslide that if, gee, I see 3 or 4 trees starting to move down the hill, you know, should I be moving fast? You know, when should I be paying the most attention?
That's a great idea, and, you know, something that another thing, you know, like the cheaper monitoring, I think that's something that I could work on liaising with the Forest Service about, is that a possibility? And can we get some information out there if they're willing to? So.
Yeah, I think the informational sign is a really good idea.
Even I have to admit, I have to read the whole thing, not just the, it will occur at 5:30 at the Cordova Center. We'll have dinner,
Yeah.
Yeah. I was pretty proud, I got far enough to know it wasn't.
Yeah, and kind of touching on your previous point, about how hard it is to get people's attention. I think, one of the things that's super important is just having multiple channels of communication. Like you can't just rely on everybody's going to read the sign or everyone's going to read the Facebook post. And so that's, that comes back to like the resources in the project itself, which is something that, as we build out these proposals, we can think about like, what do we really need to have in order to like have communication that really like gets through to multiple groups of people, and you don't just see it once, you see it many times. Yeah.
I know that if you put a piece of paper along the sign that's at the Sheridan Lake, I probably won't see it because it won't look new enough. I'm so used to seeing something there that I would not stop to see if it's something new.
Yeah.
And so that it is gonna have to be something that kind of jumps out at people as, hey, this is different. That is
Motion sensitive on the sign. And when you get so close, all of the voice. I was like, run.
You had
my wife's voice going, hey, time to start reading here, buddy.
Were you trying to jump in too on that?
Long time Facebook to me, I get on there and I could spend 3 or 4 hours. At the end of it, I go, what did I get on? I can't remember. So I try to stay away from it much. Then the comments and stuff they go south. It's not the people I know. So, and then, it's people have other pressing issues. I mean, there's fishery. There's so many things to say that, well, they're not paying attention. Well, you can't. And he's right. If you're not paying attention, if you're not outraged, you're not paying attention. I mean, it's the very, but notifications and stuff too. I tried years ago to get this is right by the museum there. Would be a great place for I see in we're in DC one time and they had these electronic billboards that you drive by and it's right there. They've gotten pretty good now. It's not a big fonts and you drive by and you'd see it kind of everybody goes through town. We got a clock up on the wall and then we got the clock on our TV and I'm so used to looking at that clock. You get a habit of seeing the sign on front of the museum up here.
Yeah, but I don't know, I kind of feel like what we're getting to is what the sign gonna say is be scared now, be scared now. And I don't see the advantage of that. I'd rather not be scared now.
You're not paying attention because you'll get outraged, essentially, right?
No, it's more the anxiety. It's like
Or
that.
not go out there.
You wouldn't get out of bed in the
Yeah, when I
morning.
get out of bed,
Plenty
be scared now.
Yeah.
And that's different than outrage.
Yeah.
But having a sign like today, the thing we're gonna fear is a tsunami. Today, the thing we're gonna fear is, an earthquake.
That's a really good point. I wonder if it could all, thinking again, going back to avalanches, it's like today, or wildfires, today the risk is low, today the risk is medium, today the risk is high. I wonder, something like that might be a more effective way to communicate risk in this situation.
It sounds like though,
Yeah.
you couldn't tell what the risk was.
Mhm.
But maybe something
Yeah.
small and it turned out to.
True, there's still a lot of
I couldn't
uncertainty.
believe it. We're gonna, USGS or whatever, put out these earthquake forecast maps now.
Yeah,
It's just like, man, just get me worried here all about everything. Like you say, what is it this morning? We're gonna,
Mhm.
you know, I went up into Barry Arm this summer and I go, yeah, there's something I'm supposed to be worried about. Okay, I'm not going to the base of the slope, but I'm out here in front of, you know, Cascade and taking this in, went over to Surprise Glacier, which surprised me as far as how far it went back. And then I started looking around a little more and I go, I should really be scared of this place. That was really, and I know they had a medium landslide in there not too long ago, like earlier this year, last year. And I could see where that came and where some more are gonna be coming. That was a surprise at Surprise Glacier, but I wasn't there that long and I think it was worthwhile to have gone there. And it is what you decide to driving out the highway here, that whole slope all along like where you live, Scott, it's some pretty steep treed areas that in a big rain and wind, any of those can let loose across the road.
I live with the fantasy that there's a valley just on the other side of that bridge.
Valley there.
You know, that there's a stopper before it gets to my place.
Maybe it'll jump over.
Yeah, well, let me live with my fantasy.
No, I think you make a really important point about, I called it fear fatigue on this.
Mhm.
Yeah. You know, talking about how do you get people to pay attention, making
Mhm.
people afraid of everything,
Mhm.
Yeah.
doesn't get people to pay attention to anything.
No.
I would say, just to jump in on that, like one of the things I've definitely seen like emergency managers approach things with, it seems pretty explicitly like trying to scare people into paying attention and yeah, I think it's really unproductive myself. You know, I think I commonly get the two kind of reactions that are sort of opposite ends that I think are both sort of unproductive. One is to get really scared of something is not actually very helpful. It doesn't, you know, it's a harm in and of itself, as people are noting, and it doesn't actually necessarily drive, you know, it doesn't necessarily, you know, actually help. Like it doesn't actually lead to higher survival rates that well or whatever. But then on the other hand, people just, you know, are like, well, that sounds ridiculous, and I'll dismiss it, and that's also not productive. And so you know, I try to approach these as, you know, something that's interesting and, you know, to try to understand what we're talking about. And then I try to make comparisons to other things that I do. I've gone through, you know, for some cases, I'm not really at that point with these things we're talking about in Cordova, but we could probably do it really roughly. I've compared it actually to what is the risk of driving, right? You know, like spending, you know, for instance, being my estimate on Portage Lake was that being an interpretive ranger there for a summer for 3 months is similar to all the risk of driving that one accrues through one's entire lifetime. It's a lot safer than climbing Everest. So, you know, if you're a daredevil, then, you know, spending a summer at Portage Lake, you know, maybe right up your alley. But I think a lot of people who do that aren't. So I think making those comparisons is a helpful way to kind of get into that.
I did that job for 3 summers, Haig.
You did? Portage Lake, really?
Yeah.
Oh my gosh.
Dodged a bullet, I guess.
Dodged a bullet. Yeah.
When you announced Barry Arm 5 years ago, that was a very scary scenario you put out. And I always say it worked. You got big funding to monitor that thing. You scared a lot of people. You got Lisa Burkowski involved, getting you money and things like that. And I thought it was a real scare tactic. So I don't know. I'm not quite sure. You saying that that's not productive certainly was for that research.
Boy, it was good to fish there that summer though.
Was it? Yeah. Again, all these tour boats go down to, the big ones go down to Harriman Glacier. That's fairly stable and safe, except the wave's gonna come in behind you. But they don't go up close to.
There was an interesting, I think Kate might have shown it another meeting or conference or something, but yeah, it showed the ship traffic going up there in 2020 compared to 2019 and or 2021 compared to 2019, and it was significantly reduced. It was, or that's probably COVID, but yeah.
Well, we went across COVID, so we skipped over COVID for that comparison. But there was a lot of reduced traffic there. I think that's kind of returned now. I think a couple of the big mistakes that we made in that, one was that we really didn't have much of a grounding in what was actually going on as far as people out there, and so we didn't really know what we were communicating about as we went into it, and I think that was a huge mistake. And then the other thing is that the science was a lot weaker then than it is now. And we both didn't appreciate how much else we didn't know. So we actually ended up driving, for instance, increased traffic at Yale Glacier. And there's another large slow moving slope there that probably poses a somewhat similar hazard. So that's not exactly a success there. We also, I think that our initial statement was that it was possible within a year and likely within 20 years. We didn't get really specific about what exactly was possible in a year and likely within 20 years. I still don't think we're too far off on that, but I think we may have overestimated it somewhat in the likelihood of something happening there. And the most likely scenarios are modest. They are like very bad if you're right there in Barry Arm, but probably wouldn't be that bad in Whittier. So I think we had there's a lot we can do to kind of improve on those kind of early, assessments of the hazard.
I think what drove a lot of the reduction in boat traffic up there is just insurance companies seeing your report and telling their boat operators, you can't go there anymore. So it isn't a decision by the insurance company. I don't know.
Yeah.
Do you have any direct evidence that the insurance companies paid any attention at all? I would be really curious to see it if you do.
I'll see if I could find something.
Yeah,
Well,
definitely interested.
I reached out to you after you put out the report originally and asked if you sent you an email, because I'd met you when you guys walked through here, and said, hey, where should I anchor? And you sent me the most horrible computer modeling of what was gonna happen. You said, oh, you wanna know where to anchor in here near here? Look what's gonna happen in Cordova. I was like, what is this? So I started ignoring what you were saying.
That's good to know. Yeah, I mean, what we've seen is that for anchorages, it's an unfortunate coincidence between where it's practical to anchor and where the risk is greatest. There's a lot of cases where if you were, under power, you're not in too bad a shape. But if you actually go into the places that make sense to anchor, those are often the places where tsunami impacts are at their worst. And, it was very, very close call in Tracy Arm with, vessels that were going into that area. There was, if it had been 24 hours earlier or 2 hours later, there would have been, definitely would have been vessels that have been right where in areas that got hit really bad. So, I mean, I think that that anchorage question is a really good one, and a tough one to answer. Like, it would be nice to see more systematic look at that.
Sounds like maybe a good potential research question or understanding kind of where safe harbors or safer harbors might be in different situations. Great. Well, thanks, folks. This is really a great conversation. I think that, there's, as we talked about, like, we don't want to cause fear. There's still a lot of uncertainty around a lot of these events and the possibility of them and when and how big they will happen. And so that is part of our goal with with these research proposals, if we're able to get them, is to understand them better so that we can decrease that uncertainty and talk a bit more about how can we communicate these without saying everything is horrible and terrible and you have to be afraid of everything. Because as we know, we're out there all the time. People are out there all the time and these events don't happen. But I think it's also really good to be aware of them and to learn more about them as we see them happening a little bit more frequently, even though they do tend to be in remote areas. Yes, we would, it sounds like there's a couple of things that I took away from this that I will follow up on totally independently of the Arctic T-slip project, including potential monitoring, looking into what we can do at Sheridan, and maybe talking about or thinking a little bit more about how we can communicate that risk at Sheridan in a way that makes sense if we have some monitoring equipment up there. Any closing thoughts or anybody, Kristen, Bex, Haig, anybody like to?
No, just thank you for the great discussion.
Thanks, Haig.
Yeah, thanks everyone for joining in, and I'm really happy to continue those conversations. So hope we go there.
Thanks for sticking with us for an extra long Tuesday night science talk. I really appreciate it.
Thank you.
If anybody wants to
Great,
grab a few
Hig.
sandwiches.
Have a good night, Hig. Bye.
See you later.